there! Let's talk about building functions. So here we have a problem. Let's read it. You open a savings account with $400. Every month, the bank gives you an additional $50 into your account. Assuming you don't remove or put any more money into the account, how much will you earn after 1 year? We have all the information. In order to solve this, we need to make a function. Let's call the function f of d. So from our last video, interpreting functions, we can say that d is how much money you get every month. And f of d is your overall money. So let's make an equation here. We know the basic format has to do mx plus b, assuming that this is linear. We know that. So instead of x, let's call this d. That's the first step in our equation. We know m is the slope. Now, what do you think is a constant in this equation? Well, we have 400. That's how much you start off with. And every month, and 1 year. And every month, the bank gives you $50. That's a constant because every month you get $50. It doesn't change. Next month, another 50. Next month, another 50. So that would be our constant here. We can say m is now 50. Now b is normally, in an equation, it's the number we start off with. How much is this one-time additional? Here, we know the additional is 400 because you start off with 400 when you open your savings account. So b would be 400. And that is our equation. F of d equals 50 times d plus 400. Now, what are we trying to solve? We're trying to find out how much you'll earn after 1 year. We know that every month you get $50, so we know d is every month. Let's write that down. D equals per month, number of months. F of d equals total money after 1 year. So we'll just say total money. Now let's solve. How much will you earn after 1 year? 1 year is 12 months, so we can say d equals 12. Let's input that. F of 12 equals 50 times 12 plus 400. 50 times 12 is 600 plus 400 equals 1,000. And that's a whopping $1,000. Let's try it with another problem here. Alright, so here we have another problem. Mr. Smith weighs 500 pounds. He is put on a diet that allows him to lose 30 pounds every month. Mr. Smith's goal is to be 200 pounds. How many months will it take him to reach his goal? There are all the key parts. So now let's kind of dissect this. 500 pounds, that's the starting amount here. So let's write another equation. Let's say pounds. So let's say f of p equals, so mp plus b, and we'll fill in the parts as we go. He weighs 500 pounds. Now, first thing you want to know is that we should be decreasing here. So instead of mp plus b, we'll do minus. And another key thing you have to know here is that the constant should be less than the starting this time because we're decreasing. So actually, we'll switch this up. We're going to actually say b minus mp because the starting amount is his starting weight, which is 500 pounds. So now that we know his starting, 500, now we have to find out the constant. So what do you see here? Well, we know he loses 30 pounds every single month. That will be our constant because that is very steady, just like the last problem. So 30 pounds, and that's all the information. And we have his goal as well. So let's write this down here as 200. And now we can mark the variables. P will be every month, so number of months. And f of p will be final weight in pounds. Write that too. And now we can solve it. We have our variables, and now we just need to solve. So we have f of 200 equals, now the key thing here is we know that his final goal is 200. So we're not solving for f of p, because if we have a number we want to solve for, we would just put it in like that. But really, we already know what's f of p, so now we're finding how many months instead of what is his final goal here. So it's kind of switched up a little. So let's solve this. Move this to the other side. We would get 300 equals 30p. And divide by both sides, p equals 10. So it would take him 10 months to reach his goal. Let's move to another kind of similar topic here, dealing with creating functions. So here we have two linear functions, f of x and g of x, and we can use any other variable we want. Now what we want to do here is add, subtract, kind of use these functions in operations. And the notation here would be f plus x, f plus g. So we could say like f of x plus f g of x. What we would do here is we would just form them together. So add them together, 7x plus 2. Now a harder example would be, well, we can subtract, we can multiply, we can do all that stuff. But the hard stuff really here is when we would have to substitute a function into a function, integrate them together. So let's say we have f of g of x. At first you'd be thinking, whoa, I don't know where to start, this is really confusing. Well, you will have to start in the center, as that is the only way to start here, at the center. So first we know, right here, g of x. What is that? Well, we can substitute in 3x. So then, our next step here, so we know f of 3x, substituting g of x equals 3x. So we have f of 3x. Well, we know f of x is 4x plus 2. So we can actually substitute this as x. And into this formula, f of x equals fx 4x plus 2. That would be 4 times 3x rather than x, because we're substituting them, plus 2, which would be 12x plus 2. Let's try that again with a different function here. Now here we have a quadratic and a linear equation, and g of f of x, let's solve this using the same method here. G equals, just plug this in here. For this, 2x squared plus 2, and then we can plug in this whole 2x squared plus 2 as x, so we would get 5, plug it in, 2x squared plus 2 plus 1, and that would be 10x squared plus 10 plus 1, which is plus 11. And let's try one more example. Let's flip it up, actually. So let's say instead of g of x, we have f of x of g of x. So this is a little harder, but you can pause this video and try it yourself, and I'm going to quickly do it right now. So let's use the same steps. F x 5x plus 1, then we can plug it in. I'm giving myself space here. 5x plus 1 squared plus 2, and now we have, and you can quickly solve this to get 50x squared plus 20x plus 4. And that's all for building functions. This has been provided to you by SATFreePractice.com.